Hello. I had a few questions about the scientific notation operations that are found in the assessment 1.1. And so I'm making a quick video to hopefully help answer some of your questions and maybe give you kind of a crash course on scientific notation to help you out with this assessment. So generally the idea of scientific notation is a shorthand or a way to express very large or small numbers without having to use so many zeros. And so if we're going from standard form, which is where we have the number written out with all the zeros, to scientific notation, you want to think about where the decimal should be placed. And so the decimal is always going to be in between the first two numbers. So we only want one number to the left of the decimal. So in the first example here, we have 3.78 as our number. And then we want to think, how many times do we have to move that decimal place to the right? And it turns out we'd have to move it 12 places to the right of the standard form. So we have 3.78 times 10 to the positive 12. Now, if we have a very small number, we'll be thinking about where the decimal place should be, which should be between the 6 and the 4 in this case. In this example, we're moving, example number 2, we're moving to the left. When we move to the left, we use a negative exponent. So in this example, we moved left 7 times, so we have 6.4 times 10 to the negative 7. Again, remember, we only want one value in front of the decimal place. If we're going the other direction, suppose we're going from scientific notation to standard form. So if I have a value like 3.6 times 10 to the 5th, we want to take that decimal place and move it again. It's a positive exponent, so we want to go 5 places to the right. The second example, we have 8.43 times 10 to the negative 7. Negative exponent tells us to go to the left. So that's the idea of scientific notation. Let me go back one more. On your homework, you'll probably see something that looks like this. A small country has a population of 5.6 times 10 to the 9 in 1990. Since then, that population doubled, and an additional 9.3 times 10 to the 10 people have immigrated into the country. What is the population of the country now? So in this case, we have 3 steps. We want to double the population. That's our first step. So we take 5.6 times 10 to the 9th. We add it to itself because we're doubling. Notice when we add in scientific notation, or subtract really, we want to add the first 2 numbers. So 5.6 plus 5.6. And then we leave the same exponent that we started with, 10 to the 9th. The next step, notice here, we were just saying on the previous slide, scientific notation has to have the decimal place in between the 1 and the 1 here because we only want one value to the left of the decimal. So here, next step, we're going to change the form. If we change 11.2 times 10 to the 9th, if we move that decimal place once to the left, we're going to raise our power from 9 to 10. So that's how we get from 11.2 times 10 to the 9th to 1.12 times 10 to the 10th. The last step, now we know what the population is when it's doubled. We want to add on that 9.3 times 10 to the 10th. Notice this works out nicely because we would not be able to add 11.2 times 10 to the 9th to something times 10 to the 10th. In this case, we can go ahead and take our 1.2 times 10 to the 10th and add on 9.3 times 10 to the 10th. We add those first 2 digits and we leave the exponent the same. Notice here again, we're not in scientific form. So we would want to move that decimal place once to the left, raise the 10 to the 11th power. And if we wrote that out in standard form, we'd have 104,000, not thousand, let's see, that's billion, 104,200,000,000. And so when we're entering our answers in this case, Here we want it in this a plus 10 to the b format. And so our a here is our beginning number, which would be the 1.042. I think MyOpenMath is being a little tricky in some places, and sometimes it's not changing. Sometimes it will count 10.42 times 10 to the 10. Sometimes it wants it written as 1.042 times 10 to 11th. So in this case, all you would put in for b is the exponent, which would be 11. You don't have to write the 10 or any kind of exponent there. Just put the number in. So I would put 1.042 for A and 11 for B. The next type of scientific notation problem we have is multiplication. If we're multiplying two numbers in scientific notation, we take the first two numbers and multiply. So 7.4 times 3.8 gives us the beginning number, 28.12. And then the next thing we do is add the exponents of the tens. So the first exponent is negative 15. We add 14, we get a negative 1. We put that all together and we get 28.12 times 10 to the negative 1. Again, that could be rewritten as 2.812 times 10 to the 0. The last example is dividing two numbers in scientific notation. The rules for dividing in scientific notation is we divide the first two numbers and then we subtract our exponents. So here we would take 8.82, divide by 2.1, we end up with 4.2. We look at our exponents, we have 17 minus a negative 25. If we're subtracting a negative, that actually acts like an addition problem. So we have 17 plus 25, which gives us 42. And our final answer comes out to be 4.2 times 10 to the 42nd power. I hope that these examples help, and if you still have extra questions, I am around Tuesdays and Thursdays from 2 to 3 in Collaborate. I will send that link out for you all, and really by appointment on Fridays as well. So feel free to email me your questions or let me know a time that you need to meet up on Collaborate, and I'll be happy to help. Thanks.